one, it says the requirement is use the method of your choice. If I'm told to use the method of my choice, will I ever use completing the square? No. No. Okay, very good. So let's start with x squared plus 4x equals 9. What would you like to do? Very good. X squared.
One mistake already. I already started it wrong on this one.
I'm sorry?
I think, no, go ahead. I was talking
Okay.
about when I was working on it earlier.
Good. So we have 4 methods. This is not ready for taking square roots. That's done. I'm not going to complete the square. That's done. If factoring takes more than 20 seconds, it's done. What is the only option I have? Correct. It's not factorable. The product is -9 and the sum is 4. So my only chance is quadratic formula. Very good. So what would you write? Negative b, which is -4, plus or minus the square root of
B squared.
16 minus 4. I would not waste my time with writing 1 times -9. Instead of writing parentheses and parentheses, I'm going to change this into plus and multiply by 9 over 2. Did you understand what I just did? Instead of writing -4 and in parentheses -7, because I have 2 negatives, I'm changing this. So this becomes -4 plus or minus the square root of 16. 4 times 9 is 36. 36 plus 16 is 52. Any questions so far? Always correct me if I'm wrong. So 36 plus 16. I'm asked to simplify. Let's go to 52. So I will say, okay, 52 is, first of all, it ends in 2. It ends in it's an even number, so it must be divisible by 2. So I'll put 2. And this is 26. Well, 26 is also an even number. So then I have 2 and 13. So therefore, I will continue writing -4 plus or minus the square root of 4 times 13 divided by 2. 52 was broken up into 2 times 2 times 13, which means 4 times 13. Now, I have to simplify the square root of 4 times 13. So -4 plus or minus 2 times the square root of 13 divided by 2. Do we all agree? Now, I have to continue with one more step. One thing that I am kindly asking you not to do is this. If you do this, it's a terrible mistake. So, in order to simplify, I have 2 options. -4 plus or minus 2, the square root of 13 divided by 2. One option is to separate the 2 fractions into -4 over 2 plus or minus 2, the square root of 13 over 2. Or the other option is to factor out at the top what? 2 indeed, and what is left in parentheses? -2 plus or minus the square root of 13. The answers will be the same. I simplify, so I get -2 plus or minus the square root of 13. And here I get the same thing. -2 plus or minus the square root of 13, because I simplify the fraction by itself and the fraction by itself. So both answers are correct. So now, I cut you off for just 1 second because I want to see what Karina put in there. So what did you put? I'm just curious now. So,
Oh, I guess I did.
you are correct, but what happened? Can I show everyone?
Yeah, no,
You
that's
allow?
fine. I don't know what I did.
Okay. So what happened was
Oh,
you
I see.
wrote everything under the square root. So I will give you the point
Okay,
because what you did is correct, but you
I
right
see.
here you extended.
gotcha.
You extended by mistake. You
Yeah.
forgot to put the comma
Right,
and get out of the square root.
okay.
Okay.
I didn't know that.
So Don't redo the problem.
Okay.
That's what I said. If
Yeah,
you,
that's what email.
yes, no problem. I'll give you the point. I'll be very happy to do that. Okay, so the other problem that we are looking at is 1 over x plus 1 over x plus 2 equals 1 over 4. From the very beginning, I forgot to ask you, what type of equation is this? Quadratic. How many solutions do we have to find? 2. Very good. So now I'm going to ask you, what type of equation is this? Yes, it is a rational equation, but I can't say how many solutions you will have. That part is not clear. Okay, what do I have to start with? Very good questions. Thank you. What do I have to start with? Never. So I have to state that x is not equal, and from here x is not equal, and then I have to move 1/4 to the other side. I'm not forcing you to use my method, but I have to use the method I presented already. So x not equal,
0.
and x not equal, perfect. Now I have 1 over x plus 1 over x plus 2 minus 1 over 4 equals, of course, if I don't write 0, I'm in big trouble. Only now, at this stage, I find the LCD, the least common denominator. What is the least common denominator here? How many different factors we see? 3 different factors. All have to be in the LCD. Otherwise, we will not have answers to our questions. On the other one, you did the exact same thing. You just extended the square root.
That's it.
Don't do them again. Okay, so what is the adjustment for the top of x? 4x plus 8. Very good. 4x plus 8. What is the adjustment on top of x plus 2?
4x.
Perfect. What is the adjustment on top of 1?
X squared plus 2x.
Very good. X squared plus 2x. Awesome. If you have questions, stop me, please. Don't be shy. So can anyone dictate the numerator now?
4x plus 8 over x. Or, no, 4x or plus or minus x squared plus 2x. Or minus 2x.
Good. When we distribute, we have to distribute to all terms. Very good. Excellent. So now, what do I do next? Combine like terms. Put everything in descending order. So negative x squared is first. This is 8 minus 2, which is positive 6x plus 8. And now I write 0 over 1. What am I telling you here? Once I write 0 over 1, what am I really telling you? Indeed, awesome. That this is a proportion. So this times 1 will be negative x squared plus 6x plus 8 equals this times 0, which is? Very good. What type of equation is this now? Good. But I see it has a negative leading coefficient. I refuse to solve a quadratic equation with a negative leading coefficient. So what should I do?
Multiply negative x 1.
Very good. Get rid of that. Very good. So this is x squared minus 6x minus 8 equals 0. It's not factorable. The product is negative 8. The sum is negative 6. What is our only chance? I shouldn't say only chance, but what is the one that we are going to go with?
Factor.
The product is negative 8. The sum is negative 6. So what is the other option? That's it. Negative b. Very good. Plus or minus. No, negative b. The b is -6 with minus in front is +6. Plus or minus?
-6. Squared.
I don't want to see a negative number in there. Perfect, correct. So minus 4 times 1 times -8. I changed into positive times 8. Divided by 2. So now this is 6 plus or minus 36, 40, and 4 times 8, 32. 36 plus 32. 60. Good. I take 68 aside and see what this means. It's an even number. I have to start with 2. Then I get 34. It's still an even number. I have to continue with 2, and I get 17. So therefore, x equals 6 plus or minus the square root of 4 times the square root of 17. So x is, if you want 6 plus or minus 2 the square root of 17 divided by 2. You cannot simplify. You either separate and then simplify or factor. So the simplified form is x equals 3 plus or minus the square root of 17. How I did that? 6 divided by 2 is 3. 2 over 2 is 1. So you didn't make any mistake. Good. Anything else for me? Very good questions. Good warm-up. So now let's continue. If you have other questions for me, please. Yes, yes.
There was one. The problem was p to the 4th minus 16.
Let me write it. Sorry. Yes.
P to the 4th minus 16.
Okay, so we're asked to factor. This is what type of what? What type of polynomial? Very good. It's a binomial. Good. My first question to myself, remember the scheme. Descending order. Greatest common factor. Do these two terms have a common factor? No. Negative leading coefficient? Good. So then I'm looking at the special product. So it's either the difference of cubes or the difference of squares. Or none of the above, and I'll say it's not factorable. Difference of squares. Once you say the difference of squares, then you will come up with two binomials. So let's see what is the first binomial all about. P squared. And very good. Which of these two is not factorable anymore? That is the difference of squares. We just used it, so it has to be factorable. So which of these two is not factorable? It's in the handout. We wrote it last time in the factoring document. So which one is not factorable anymore? If it's not the difference of squares, because we just applied it, so it must be the sum of squares. This is not factorable, right? Not factorable any longer, so I don't have to worry about it. But can I factor p squared minus 4? Because the difference of squares, and once you say that, you will give two binomials. What are those binomials?
P plus 2p minus.
That's it. Good. Perfect example. Anything else for me? Anything else for me? Have you tried anything else? Do you want to see anything else? Anything? Okay, we're moving on to our review. So it's 1.6 other types of equations. Don't forget to bring the handouts that I gave you on the first day of classes. Bring them to class, because on Thursday I would like to look at one of those handouts with factoring, so we can put that aside. Okay, other types of equations. We have so many different types. So here's number 1. polynomial equations. So I'm just going to go ahead and pick a problem. On page 185, let's start with problem 2, which it reads 5x to the fourth minus 20x squared equals 0. Okay, so first I'm asking myself, what type of equation is this? It is polynomial equation. What is the degree? How many solutions will I get? Of course, 4. 4 solutions. I write myself a note so I don't forget. Even if they're all the same, and you'll see what happens in the next chapter when some of the solutions are the same. So if the degree is 4, we have to find 4 solutions. My next question to myself is, can I simplify this? How?
Take out 5x squared.
I will divide both sides by, I can never divide by x. Let's write a note. If you divide by x, you omit 2 solutions. You can never divide by x. Never divide by the variable or expressions containing the variable. We can never divide both sides of an equation by the variable or by expressions that contain the variable. That is never allowed. But yes, to simplify by 5, sure, who cares about 5? The solutions will not change. So x to the fourth minus 4x squared equals 0. This is much easier to work with, so that's what we are going to do. Very good. So now I know it's a binomial. It's in descending order, greatest common factor. Very good, awesome. What is left in parentheses?
X squared minus 2, 4.
Perfect. Now what do I do with x squared minus 4? Very good. We just did that. Very good question. Now I would like you to give me 4 solutions. Even if some of them are the same. With x equals negative 2. Very good.
0, 0.
Very good. Awesome. So we have 2 factors of x. X times x plus 2 times x minus 2. So that's why we have 2 solutions that are 0. Any questions on this problem? Please don't be shy. If some of your colleagues answer before you do, it doesn't mean that I'm trying to leave anybody behind, because I'm not. So always ask questions if you have anything on your mind, please. I learn from your questions. So for example, today, one of your colleagues in the same class said this to me. And I have never, ever thought of saying it, ever. She said, I don't understand the difference between you solving an equation, a quadratic equation by factoring, or solving it by completing the square. It's a brilliant question. Here's why. Because we did use factoring to solve quadratic equations and that changed into a binomial square. And the complete the square, that's what it is, a binomial square. So it was a brilliant question. Because I have never ever had that question before. I never thought of saying, hey, look, when you factor, you have 0 on one side to solve the equation. When you complete the square, most of the time you don't have 0 on the other side. You have a number. That's why you take the square root from both sides. It was a brilliant question. So I learned from you, and I hope you learned from me. Any questions on this? Okay, do we need another polynomial equation to see? Yes, okay, perfect. So let's say problem 6 on page 185. And that is x plus 1 equals 9x cubed plus 9x squared. I look at the equation and I ask myself first, what? I know I sound like my grandma. It's a polynomial equation, perfect. Now, how many terms does it have? 4. What is its degree?
3.
How many solutions will I find?
3.
Good. What do I do with 4 terms? There is only one option. There is only one answer for 4 terms. Grouping. Grouping. That's all I want you to say. So now please dictate. What do I do?
Take the 1 and the other.
Yes, 9x cubed plus 9x squared minus x minus 1 equals 0. It doesn't matter if you put 0 on the left or 0 on the right. So we moved x and 1 to the other side. Awesome. Thank you. Good. Now, what do you think I'm going to do next? And I know you know the answer.
Chapter.
Awesome. How? We already said that how.
Grouping.
Grouping. Very good. So then, good. So, from the first two, very good. What is left in parentheses?
X plus 1.
Very good. What do I have to have from coming out in parentheses from the other two? Otherwise, I cannot continue. And I have to have the equal symbol and 0.
X plus 1.
It has to be x plus 1, and only now I look.
-1. Oh,
Very good. So what is the common factor that gets pulled out now?
X.
Awesome. And what is left in parentheses?
9x squared.
What do I do with 9x squared minus 1?
Factor.
Good. How many solutions did we say?
3.
Good. Please give me 3 solutions. -1, perfect. So I move 1 to the other side, it becomes negative, and I have to divide by 3. 1 moved to the other side is negative, and divide by 3.
So 1/3.
-1/3. And from here, +1/3. So this is the way we solve polynomial equations. Any questions for me? I know it was kind of fast, and let me know if you have questions. Is this okay, everyone? Okay. The next type is radical equations, type 2. Okay, I'm going to pick, let's say 14 on page 185. The square root of x plus 10 equals x minus 2. Okay, many of these are equations are reviewed, but I would like to go over all of them, all different types. Okay, so first I'm going to ask myself what type of equation this is, because we know so many by now. We know linear, we know rational, we know polynomial. We will look at radical equations, so it's a radical equation, and so on and so forth, and we are going to add more types later on. Okay, so it's a radical equation. Now, please remind us, the square root of 2 is 2 raised to which power? It has to be a fraction.
1/4.
1/2. So the square root is the same with power 1/2. Therefore, in order to eliminate power 1/2, what do I have to do to both sides? Square, not multiply by square. Good. Now, if I have the cube root of 2, what will that be? 2 raised to which power? 1/3. So if the square root is power 1/2, the cube root is power 1/3, and so on and so forth. Before we continue, I want one more thing to clarify. Is 2 plus 3 the same thing with 5? You can never do this, because 4 plus 9 does not equal 25. So the point I'm making here is, you cannot put a square here and a square here and a square here. Point I'm making one more time is the left-hand side has to be squared as 1 unit, and the right-hand side has to be squared as 1 unit, not term by term. because this will not be correct. Good. Can anyone tell us what is the left-hand side? What does it equal to when we square the square root? Right, we clear the radical on top of it. Before you answer for the right-hand side, please remember the agreement we made on the first day of classes. Please. Very important. That's why I started with that, because it pops up all the time. So please give me the answer for x minus 2, everything squared.
X squared minus 4.
Which one is it? So if this is minus, I can never put plus here, right? So if this is minus, this has to be minus. And then? Very good. Not 4, but 4x. 3 terms. We wrote that on the first day of classes, last week. A binomial squared has how many terms? How many? No, not 2. A binomial squared has? Let's go back to the handout from the first day of classes. The first hand is a trinomial. So x squared minus 2 times the first times the second, and plus 4, the second term squared. Please remember, we are falling behind, and you'll always hit a wall if you don't try to practice this. X minus 2 squared is this. Okay, then what type of equation is this now? Very good. How many solutions? Perfect. What do I have to do? Move everything to one side. So x squared, I bring negative x and I bring negative 10. So minus 5x and minus 6 equals 0. So I subtract x and I get negative 5x, and I subtract 10, I get negative 6. Is everyone with me? Okay, so then we have 4 methods of solving such an equation. Complete the square? No. Taking square root, it's not ready. So I'm down to 2 options. What are they? Factoring, or if it takes 20 seconds, factor. If it doesn't, forget it. Quadratic formula. So, does it take 20 seconds to tops to factor? Yes, it does. So then, what do we have? X minus 6 and x plus 1. I agree. Therefore, we have 2 options. Yes? Very good. Now, when we solve radical equations, yes, very good. We have no clue if they work in the original problem. Here's the reason why. When we raise both sides to a power, I'm not talking about the square root of both sides. When we raise both sides to the second power, the third, the fourth, the fifth, we may create a new equation that does not have the same equations, the same solutions with the original one. It's possible. So therefore, we have to go back, not here, but back to the original problem, replace x by 6, and later on by negative 1. So let's replace by 6. 6 plus 10. The square root of 16. 4. 6 minus 2. Is 4 the same thing with 4? I will say yes. Acceptable. Now I'm going to check negative 1. Negative 1 plus 10. The square root of 9. Negative 1 minus 2. Is 3 the same thing with negative 3? And I will call this an extraneous solution. This is perfectly correct here. It's perfectly correct here. It's perfectly correct here, and it's perfectly correct here, but not in the original problem. Because this is not the original problem. This is the way we solve radical equations. Would you like to see another?
Yes.
Perfect. If you have your book, you can choose. If you don't have your book, I will choose. Which one is it? Okay, I will choose. So let's say number 20 on 185. The square root of 2x plus 15 minus 6 equals x. How many radicals does this equation have? Of course, it's a radical equation, but how many radicals does it have? One radical. We need to isolate that radical. Look what happened here. The radical was isolated. Here, the radical is not isolated. What do I need to do? In other words, clean it up, bless you, and simplify.
Add 6.
Add 6 to both sides. So I have the square root of 2x plus 15 equals x plus 6. I like to keep everything in descending order, so I did not put 6 in front of x, but following x. Good. Now the radical is isolated. How do I solve the equation? Very good. It's ready for that. Good. So when I square the left-hand side, I know what I get. Now be very careful with the right-hand side. I want the correct answer, please. That's why we reviewed
Square plus 12x plus 36.
a binomial squared is a trinomial. First term squared plus 2 times the first times the second plus the second term squared. What type of equation is this now? What do we do to it? Very good. X squared. I subtract 2x and I subtract 15. Do we agree with x squared plus 10x plus 11? We do? Everyone? So I subtracted 2x and I subtracted 15. Oh, 21. Yes, yes, yes. 21. Sorry. Good. Sorry. My apologies. Good. So then if factoring takes less than 20 seconds, I'll do it. If not, quadratic formula. Very good. Product is 21, sum is 10. Very good. So therefore, we have two options for x. Both may work, one may work, or none. We'll see in a moment. I don't know. So x equals and awesome. I'm happy when I hear more voices because I want to make sure that everyone follows. So -3. Thank you for that. Okay, I'm checking -3. 2 times -3 is -6 plus 15. 9, the square root of 9. 3 minus 6. Is that -3? I'm going to say acceptable. Now I'm checking -7. -7 times 2. -14 plus 15. The square root of 1. 1 minus 6. -5. The right-hand side is -7. Is -5 the same thing with -7? No. Not acceptable. This is the principle of powers. When we raise both sides to a power, it's possible that we get what it's called extraneous solutions. Are we okay with radical equations? We isolate the radical, we square very carefully, then we get whatever, and we solve that equation. We must go back to the original problem and check. Okay? Is that okay? Good. The next type, number 3, equations with rational exponents. Equations with rational exponents. Okay. On page 185, same page, let's look at 34. And this is x plus 5. It's 5, sorry. Raised to 3/2 equals 8. Well, it is an equation with a rational exponent, obviously. But what does this really mean? What does this really mean? It's the square root of x plus 5 to which power? That's it. So it's basically a radical equation. Do we have to change it into a radical equation? No, we don't have to. Okay, so I recommend first we eliminate the denominator. What should I raise both sides to eliminate the denominator? Remember the denominator is, so this is 1/2. So it's just like the square root. So what do I raise both sides to eliminate power 1/2, basically? 2 indeed. Exactly what we just did. The left-hand side becomes, yes, right. The right-hand side is 64. The left-hand side becomes, very good. On this problem, I'm not sure what they want. Let's read the question. Solve each equation with rational exponents. Check all proposed solutions. Here's what I'm saying by I don't know what they want. What type of equation is this now? Is it linear? Is it rational? No. Is it quadratic? No. It has what degree?
3.
So it has to be a polynomial then. Awesome. So if at this stage I apply what to both sides? The cube root of both sides. How many solutions will I get?
1.
Only one. However, if I factor, if I move 64 to the other side and set equal to 0, how many solutions will I get?
3.
So I don't know what they want. So if they want all possible solutions, because that's what I think it says, if they want only the real solution, then I will take the cube root and I'm done. But if they want all possible solutions, then I cannot take the cube root. So let's assume that they want all possible solutions. So now this becomes polynomial, and it has degree 3. So there are definitely 3 solutions. I don't know. We can look at the end and see what they, but to me, it's very clear. They said solve each equation with rational exponents. So I have to solve. It doesn't say only find the real solutions. So I have to find everything. It is a polynomial equation now. I move 64 to the other side. Now, we reviewed this last time. So let me refresh your memory for a moment, and then I'll ask you what to do next. Imagine that here I have a cubed, and then I have here b cubed. If I show that this is a perfect cube, and I know that this is a perfect cube, then how will I factor a cubed minus b cubed? Can anyone give us the factored form? When we factor the difference or the sum of cubes, we have to have, very good. What is the sign for a cubed minus b cubed? What will be the sign inside the binomial? Very good. What will be the sign in the middle? Very good. The last one, we don't even discuss it. It has to be positive. Ready? So what do I have here?
It's a minus b.
Very good. I have to use this now. I have no choice. Because if I only take the cube root, I find only one solution. Okay, good. So from here, please tell me, what will be the binomial? What do I cube to get x plus 5 to the third? Good. Minus. What do I cube to get 64?
4.
Very good. So this is my A and this is my B. Forget about the rest. Now I have to follow this pattern. What is A squared?
X squared.
X plus 5 squared. Plus, what is AB? 4 times?
4x plus 20.
Yes, but let's write it for everyone to see first like this. You're correct. It is 4x plus 20. And then plus,
16.
that's it. So the binomial becomes then
Plus 1.
very good. Now please tell me how to expand this, and this is our agreement from the first few minutes of our class. So if somebody says x squared plus 20, then that person makes me cry.
2x plus 10
So x squared
plus 10x.
plus 2 times the first times the second, very good,
Now plus 25.
plus 25. A binomial squared is a trinomial. Maybe you didn't give it enough importance last week, but now since you see it, it appears all the time, I'm hoping that you're going to look at that. And indeed, plus 4x, plus 20, and plus 16. I already have the first solution, so I can get rid of it. Very good. And now 2 solutions will come from here. Please simplify and tell me what to write.
X squared plus 14x.
So 25, that's 45. 45 plus 16 is 61. Very good. Don't try to factor. This is not factorable. The product is 61. The sum is 14. Good. What is my only chance then? Very good. Negative b, negative 14 plus or minus the square root of 14 squared, leave it like that for now, minus 4 times the first times the, I'm sorry, minus 4 AC over 2a. So I grab my calculator to perform the operation under the square root, because now I'm sure that they want no approximations. Minus 4 times 61, so negative 48. So this is x equals negative 14 plus or minus negative 48 divided by 2. What do we know about the square root of negative 48? It's the square root of negative 1 multiplied by the square root of, multiplied by the square root of. 48 is 16 times 3. So this will be I, this will be,
4.
very good, so 4i in front, the square root of 3. So x equals negative 14 plus or minus 4i the square root of 13, not 13, I'm sorry, square root of 3. I don't know how I came up with 13 over 2. You cannot simplify in a sum, but you can separate. Negative 14 over 2 is negative 7, and plus or minus 4i the square root of 3 over 2 will be 2i the square root of 3. A lot of work on this problem, because it became a polynomial degree 3, and we had to find 3 solutions. Here's the first solution, and here are the other 2. Yes, please.
So I just noticed that if you take the cube root of where we split off between the real and all the solutions, when you take the cube root, the solution of that is the same as the binomial once you split
Correct.
it. So is that a consistent trend?
Yes.
Okay.
Absolutely. Yes. Any questions? Very good question. Thank you. Okay, let's look at another one of this type. Yes, let's look at 36, which is 8x to 5/3 minus 24 equals 0. What type of equation is it? It's with rational exponents, clearly. Okay, then what will be my next step?
Eliminate the denominator.
Not yet. It's not cleaned up, but yes, you are on the right track, but first we have to clean it up. So how do I clean this up?
Cute everything.
That will be a tremendous work, and it will not help. No. Remember, the second question ever when I'm asked to solve an equation is, can I simplify it? Without doing that, I will get into more and more trouble. I'm only hoping to be able to simplify. So, what do you recommend? Say it again. First, I will have to move 24. 8x to 5/3 equals 24, and then I will divide both sides by 8. That's how I clean it up. So then I have x to 5/3, but it's not wrong to divide first and then move 3. It doesn't matter, really. Good. So at this point, I would like to eliminate the denominator of the power. What should I do to both sides in order to eliminate the denominator of that power? Awesome. So this is x to the 5th equals 27. Questions? Now I'm in trouble. Because again, if they want all 5 solutions, this is polynomial, and it has 5 solutions. Well, we don't know how to proceed here, because x to the 5th minus 27 equals 0. We don't know how to factor this. It will be, we can, but we will not be able to solve the next one. So at this point, I have to assume that they only want the real solution. So what do I have to do to both sides? To eliminate power 5. But it's not clear. They should have mentioned just the real solution. I will mention, well, when I put the problem like this, I will mention only the real solution. So you don't have to do all this. But the book is not clear. So what do we have to do in order to get x by itself? The 5th root. And that's the answer. Just the real solution. Otherwise, we will have to find 5 solutions. Any questions? Any questions? Which number am I on? I think I'm on 3, correct? 3 or 4? 4. 4. Next type of equation. Quadratic. And you can say, again, we just talked about it in the whole section. No, this is different. Quadratic in form. What does that mean? It means the equation is not quadratic, but it can be replaced by a quadratic equation. Why would I want to replace an equation by a quadratic one? Because it's too complicated for me to solve. But if I change it into a quadratic equation, I will be able to solve. And I see cell phones, and I see very well from here. So I was hoping not to see them. Okay, quadratic in form. So here's an example. Let's say 42. We have x to the 4th minus 13x squared plus 36 equals 0. So you could say, wait a minute, you just showed this to us. It's polynomial. It has degree 4, and you will have 4 solutions. So what are you talking about quadratic in form? Why can't I find those 4 solutions? Well, We could, if we are experienced enough, we could factor this. But at this point, let's say we're not experienced enough. We will use a substitution. What substitution? It's polynomial, it's degree 4, I have 4 solutions. Well, what substitution will I use? I'm going to say let y be, and I'm looking at the equation. Which of these two x variables have the smallest power? Right, or I should have said which one is the smallest power. That's better. Well, I'm going to say that this is y. And you can say, what are you doing? Why are you calling x squared y? I will call x squared y only as long as this piece is y squared. Because if this piece is y and this one is not y squared, the method is not applicable. The equation is not quadratic in form. It cannot be replaced by a quadratic equation. So, the question now is this y squared? If it is not y squared, the method is not applicable. So if I square this, I get y squared. If I square this, what do I get? X to the fourth. When I square x squared, I get x to the fourth. So now can anyone dictate the new equation? And you can say, forgive me one second, so you can say, okay, who cares about y? No one. It's our baby. We do. The equation has to be solved for x. But we first will be solving for y because it's easier to do that. Okay, I'm ready.
Y squared minus 13y plus 36 equals 0.
Do you all agree with the new equation? Okay, now this is much easier. This we know how to solve. So, what are we going to do? Exactly, I'm going to factor. If factoring takes too long, quadratic formula, whatever. Good. So I know it's in descending order. Greatest common factor, no. Negative leading coefficient, no. Special product, yes. This is a perfect square with minus, and this is a perfect square. What do you expect to get? Y minus y minus 6, everything squared, right? This is what I expect to get. But what will be the middle term here? From the first thing we did this semester, what will be the middle term here? Not just negative 12, but negative 12. Good. Is this the one? No, so this doesn't work. Remember, I always have to check special products before I move on. So then the product is 36 and the sum is negative 13. Is there a way of factoring this? Or you say, forget about factoring, I'm going to use the quadratic formula, and I accept that. That's fine. So how do I factor this? Very good. Y minus 4, y minus 9, or vice versa, it doesn't matter, equals 0. So we do have two solutions for y. Can anyone give us those two solutions? Good. But this is basically a different equation, and this is basically a different equation that I have to solve. Remember, we used the substitution, or we changed the variable just to enable us to solve the equation, changing into a quadratic. If it's possible, I cannot just fabricate and change any equation to a quadratic equation. For example, if I have here 3, I cannot do this, because this is denoted by y, but this will not be y squared. So the equation is not quadratic in form. I cannot use the substitution. But I was able to use the substitution because this is clearly y, and if I denote this by y or t or z, whatever you want, then this will be y squared. Therefore, I changed it into a quadratic equation that factors like this, and I got y equals 4 and 9. However, the final answer has to be in x. So can anyone dictate which equation is this? What did we denote by y? So then what is this equation? What is it? And what about this one? How many solutions do we expect? Good. Which method is applicable here for sure? It's already completed.
You take the square root of those.
Very good. This is a perfect situation in which we should not factor, we should not do anything else but take square roots from both sides. X equals. If I forget something crucial, I will not solve correctly. Remember, 4 solutions. That's why we established this from the beginning so we don't forget. So this is an equation that is quadratic in form, not quadratic. A quadratic equation cannot have 4 solutions. It's actually polynomial. But it's quadratic in form because we were able to replace it using an appropriate substitution. We were able to replace it by quadratic, and then the whole thing was easy. Do we need another example like this one?
Yes.
Very good. So let's look at 52. Of course, they're all different, and I'm hoping that on Thursday when you work on this, you're going to come up with other questions. Please do not fall behind. Please do not fall behind. Okay, let me upload.